Okay, you can see we're almost finished. Everything is mounted on the chassis. We just got to put our electronics in and then we're good to go. Before we finish up here, I want to show you two other things that are very important if you're dealing with setup. And that's your anti-roll bars and our springs. So how I measure my anti-roll bars is I basically just take a piece of graph paper and I lay the bar on the paper, trace inside and outside profiles on all sides, then mark the, so you can see here I've got the front and the rear traced out, then I mark the center points and just draw lines. So now what I'll do is I'll measure the distances here and then vertically down to determine the proportions for the anti-roll bar. Obviously also we need the diameter of the bar. So the other thing is we need the not just the bar, we need the bar with the mounting pivot attached to it. So once I've got the bar itself measured, I'll put the pivot back on, or the ball cup, and I'll mark the center point of that so that I can get this point here, because those are the dimensions that I need to take. So what we'll do is just measure, where's my 1:1 scale? So I'm just using a engineering scale here, so I'll measure it 1:1, and that dimension across there is 34 in that direction, and then down this way I've got 57, so I'm 57 in this direction, and then I need my vertical dimension from my pivot point back up to this line here, which is going to be 43. So I got 43 in that direction. Okay, so we do the same thing for the front. I haven't marked the pivot point yet, but I will do that in a second. I'm not going to bore you with doing that, but that's how you measure up your anti-roll bars. It's not 100% accurate, but it's certainly close enough for what we're excuse me, what we're doing here, and it gives you a good relative comparison when you're changing bar diameters to look at different stiffness bars and so on. It's more than adequate for what we're doing here. The other thing is springs. Now in most cases manufacturers provide you with the spring rate, which is awesome, but in the case they don't, there is a spring rate calculator built into RC Crew Chief. So I want to show you how to determine the measurements that you need for the spring rates. So there is a spring rate worksheet that you can print out in the in RC Crew Chief. So what we need to take is the inside diameter of the coil. We need to take the diameter of the wire, and the trickiest bit, which is the number of active coils. What's called the number of active coils. So the inside diameter, simply, this helps you turn your calipers on and zero them. So we just measure the inside diameter, which in this case is 14.1 millimeters. So this is a blue spring, so make a note of that. So the inside diameter is 14.1. The diameter of the wire is 1.4. And now the tricky bit, the number of active coils. So you can see here what I do is I hold the spring with the top pointing upwards, and then you just count each coil. So we got one, each complete coil, 1, 2, 3, 4, 3.5, and then this coil is not complete. It goes around to that point, which is pretty much exactly halfway around. So that in this case would be 5.5 coils. Now active coils you have to subtract off, because the first coil is touching, it's considered to be inactive, and the last coil as well is touching here, so that's also considered to be inactive. So this spring would have 3.5 active coils. So there's 3.5, and we'll do a comparison when we start entering the model information between the spring rate calculator and the actual number that the manufacturer provides. Associated does provide the spring rate for this spring. Okay, that's it. Up next, we're going to put all the electronics in. We'll balance the chassis, we'll measure the center of gravity, and then we'll be ready to hit the track.